What is a microcontroller? Microcontrollers are tiny devices often used only for some specific tasks. To describe them in a better way, we should compare them to PCs. A modern computer must have the following parts: a computing part that follows the orders, a temporary storage for intermediate results and other variables, and the storage which stores the program. PCs have multi-core CPUs, several gigabytes of RAM, and big hard drives. Usually most parts are replaceable in desktops. However, laptops and tablets tend to integrate everything on the board, but focus on the topic. Microcontrollers integrate every mentioned component into a single chip. So technically, microcontrollers are small computers, and by small, I mean everything is smaller. Forget multi-core processors in many cases and welcome single-core CPUs, often running at only a few dozen megahertz, not gigahertz. The RAM is also measured in kilobytes or megabytes, not gigabytes, as well as program storage or ROM. When microcontrollers are used, minimizing the cost is usually the top priority, since the sales volume of the product can be hundreds of millions. Over 200 millions of iPhones are sold every year since 2015, so these numbers are not so exceptionally high on a global scale. So what happens when you can spare a single cent per unit by choosing the microcontroller with 128 kilobytes of ROM over the 196 kilobytes of one? That's $10 million extra money saved. Who cares if a dozen senior engineers work a month on optimizing the code to fit in the smaller storage, because the salary of them is less than 100K. Also, microcontrollers are cheap, and by cheap, I mean dirt cheap. The RP2040 microcontroller, which has a dual-core ARM CPU capable up to 133 MHz and has 264 kilobytes RAM, costs less than $1. STMicroelectronics, Microchip and Nuvoton also offers sub-dollar microcontrollers. This is not an exception. So why don't we build our computers from these cheap devices? The answer is we already do. Our computer is built from several computers. The keyboard, the mouse, the hard drive, network controller, and every major component has its own microcontroller running its own program, the firmware. No one expects a mouse to run Windows or Linux, but we want to do the mouse things, process movement, clicks, and send it to the computer, usually via USB or Bluetooth. This could be done by an ASIC, an application-specific integrated circuit, a hardware specially tailored for the specific device. Many people heard this phrase first with Bitcoin miners. Some manufacturers make processing units with a single goal in mind: do Bitcoin-related calculations as fast and energy-efficient as possible. Making a special integrated circuit for just one task can be economical. Everyone knows solar-powered garden lamps. And since the residential outdoor solar market was over $1 billion just in 2020, it's the right choice to manufacture a dedicated solar lamp controller IC like the YX8018, which costs just a few cents each. But this only works because millions of units are sold each year. Designing a new ASIC is pretty costly, can be easily over several millions of dollars. It only makes sense if the high initial cost can be spread. But what happens if some error is found in the ASIC, a new mining algorithm or mouse model comes out? The old design becomes useless and money invested in the specialized hardware is gone. Programmable computers are the answer to this problem. You don't have to scrap the whole device, just modify the program. This method helps the development, bug fixing, and enables upgrades too. First select the cheap and available microcontroller, and then make a custom software, the firmware, for our application. Even some code can be reused for the new model if they share similar parts with the older one. The high initial cost of making a microcontroller can be spread. Billions of microcontrollers are sold every year. They are literally everywhere. So, what is a microcontroller? A tiny computer on a single chip with a special software, the firmware. And this will be a big difference. Microcontrollers only run one program, the firmware. You can't just download a new app, not because it's impossible, but impractical. If you want a more flexible device, there are single-board computers, running for example Linux. They can be pretty compact too, and the software can be fine-tuned too. Microcontrollers' goal to be the cheapest, smallest, most efficient controller of a specific device. So let's review what devices have microcontrollers for their heart. Simple appliances with configurable options usually do things with a microcontroller. Most modern kitchen tools like induction or microwave ovens, coffee machines have a microcontroller. Toasters are pretty simple devices, just a dial, and it can be done with analog electronics, but the digital ones have huge advantages. All household gadgets and sensors have a microcontroller. The thermostat, wireless doorbell, alarm clock, and don't even start to enumerate all the smart stuff in a home, because even light bulbs can have a microcontroller inside. So, since microcontrollers are small computers, let's plug in a keyboard and start hacking. It would be funny, but microcontrollers don't really like jokes like this. Just like PCs, a microcontroller can do nothing practical without peripherals, but they don't have USB ports either. PCs need a keyboard, a mouse, a monitor, and similar stuff. Microcontrollers need sensors and actuators to do their job, and those peripherals are selected for the job. Who would want an air pressure sensor in a mouse? Some common external peripherals are buttons, switches, potentiometers, ultrasonic and laser sensors, relays, motors, and many different devices can be selected. Most of them cannot be directly used with PCs at all. The microcontroller and the peripherals are usually on a single printed circuit board, or PCB for short. These are tailored for a really specific application. Take a TV remote for example. It's impossible to upgrade, modify, or add extra functionality, but no one expects to do more than changing the batteries. Maybe a single more flexible PCB design is used where some components are left out if not needed. So only one PCB type must be manufactured. On the other hand, evaluation boards are available too for developers. The manufacturers know best, and those can be used as a reference. These boards can be used for prototypes or even low-volume production. If you want to learn a new microcontroller fast, first look for eval boards.